classrooms. And that's where we're all in. We're all in that riptide between meaning making and work with new technology and the slowness of the duty of care education system to take these things up. So what we're going to share with you, remember we work in a university setting, teaching mostly doctoral students and master's students, and thinking about ways in which, in that context, you know, how do we use technology to take our, Bill, are you going to put it onto the next slide? Right, thank you. Prepare those learners for the world that is changing. And I suppose we've called it generative AI comes to schools. What's all the fuss about? And certainly all of you, I think, know there's a fuss out there. You know, a huge debate. It was mentioned this morning, huge debates about the value and the impact of generative AI on schools, on teachers, on the labour force, on the way in which we do things. So we're going to share with you today three parts of our the work. No, our work is in three parts. Sorry. So the first part is the way in which we think, at least in our context, the generative pre-trained transformers come into our schools, right? And the second part, we're going to that's going to be sort of open and theoretical about what these terms mean and what the context is. But the second part is an experiment we're going to share with you in the way that we've put to the generative AI to work in our the both master's doctoral program at the U of I. The way in which we're testing it, the way in which we're looking at improving what we do. Now, the core of our curriculum in our program, the core of it relies on peer feedback because we believe in collaboration, we believe in joint learning in an online environment. So we're going to share with you what we've done in using the generative AI. First of all, we do peer feedback with humans, and then what happens when we get the AI to provide feedback using the same kind of tools. And we have some data and some information that's come out of that work already, which we're going to share with you. And then lastly, we go back to more theoretical issues around the implications of AI in general. So Bill's going to come up now and start with the first component of our presentation. I don't know if you need.
Keeps on trying to log me in. So we all know this is the aura of GPT. Those people sitting on a fancy lounge in a city. There's a kind of an aura to this world of AI and the future. But perhaps the most interesting part is you click one screen into one link into this website, and they're planning for AGI, artificial general intelligence. So part of the imagination of these people is that it'll be possible to do something which mimics human intelligence. Now, part of what we're saying, that we're going to say in this talk, is that it's actually nothing like human intelligence at all. It does a whole lot of stuff that humans couldn't possibly do and would never want to do. But one of our arguments is that it will hit absolute limits around the technology, and it can never be what humans are. So I'm going to start off with a little an essay here where I asked ChatGPT to write a history of the Peloponnesian Railway, which I happen to know too much about for my own good. And by the way, these are my pictures down the left here because I thought it needed to be illustrated. ChatGPT is not illustrated, but I thought we needed illustrations. So it crosses the Corinth Canal there, and there are all these wonderful ruins. You know, Greece is a country of ruins, and the Peloponnesian Railway is one of the beautiful ruins of Greece. So anyhow, it writes the essay here, and it wrote this in 20 seconds. You put the prompt in. See up there, I said, write an essay on the history of the Peloponnesian Railway with references. Now, I chose the Peloponnesian Railway because I know what there is to know about it, and I wanted to see what it knew about it. Okay, so I go now on to the second page, and now we're on the second page. And it tells me, firstly, it's written like an essay, you know, which is on the one hand, on the other hand, however, blah, 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 blah. And it tells me interesting stuff like, well, it was a threat to animal-drawn carts. Well, come on. I mean, you know, this is kind of, one level, it's kind of facile. And then it was decommissioned in the 1970s. Well, in fact, it closed in 2011. So that's a major kind of factual problem there. But the important thing is it's made it up, right? It's completely incapable of distinguishing between fact and non-fact. And when there's not a fact, the priority is actually on the dialogue. And I'm going to get down a little bit deeper about what the dialogue stuff means. So you'll fill the gap, just have a plausible sentence, because there should be a sentence on this stuff. But then the references I particularly like, they're completely made up. They look like really good references, but they actually don't exist. So you do a little search for them. And actually, if you say put us web links as well, the web links will be fake web links and so on. So it's kind of indicative for me of some kind of underlying problems in the whole technology. And there are some more of my photos of the ruins over there. And the text doesn't help me at all with those. Now that, come on. There we go. Now, by the way, we have a solution to this problem, because what we're going to have students doing is creating fake essays, submitting them. And interesting research in the US, recent research, is they gave ChatGPT the medical practitioner entry exam in the US, and it will pass at a third-year level, right? So to become a doctor. So one of the things is immediately, in education, there is only one solution, and we can end at this slide if you like. And the slide is proctored examinations. So one of the problems is, one of the consequences might be a set of very regressive returns to how can we know what students have learned when we have this incredible cheating machine at our fingertips. Now, mind you, we've always had cheating machines at our fingertips, which is somebody else who write the essay for us, or look up the answer when you're not supposed to. But nevertheless, this is another high technology cheating machine. So if we're not to regard this solution as an adequate one, now that, actually, you know what? If I log in, it'll keep. Oh, I know what I'll do. Let me just split the browser. So it's going to just keep doing this. That browser stops it moving on. Sorry about this. So we're going to do a little definition now. This is just sort of after initial unpacking. And what generative AI does, which is new and it is interesting, is uniquely reconstituted digital artifacts. So in other words, it's not a matter of, something which finds the picture of the train for me or finds the web page about the Peloponnesian Railway on Wikipedia. What it does, it uniquely reconstitutes text, image, sound, or something in multimodal combination. And these have been found by various machine learning mechanisms, which I've mentioned there. So in other words, these have been, sort of the world of images or text has been massaged, and these machine learning processes have kind of post-processed that. That's a long story, but that's enough. You've probably got a sense of what it is. Now, Mary and I are using this acronym here, which we've kind of invented, which is what's very interesting about ChatGPT is a very narrow version of two technologies. It's two things together, which is a chatbot, and large language models. And I want to go back and so it's basically those two things interacting. We're not going to talk about image now. That's another whole story. But here we're just going to talk about this, because that's primarily what people do with ChatGPT. They ask a question in text chat and they get a response built out of large language models. So that's the idea that we're working with. Now, the point is this technology is not at all new. So people think it turned up yesterday. And this is a very famous piece of text, a work of Joseph Weizenbaum at MIT, created the first chatbot. And the interesting thing about it, which is kind of fascinating in retrospect, it was using the logic of Charles Rogers' psychology. So Charles Rogers, as a psychologist, said, it's not for the psychologist to come in and give advice, I've got a problem, blah, 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 blah. It's just to ask a series of questions. And the series of questions is how the psychologist learns about the person. But in fact, the person ends up learning about themselves by simply answering the questions. So the nature of the dialogue is this kind of Rogerian psychology, actually, where you get drawn into it. And one of the great stories, this was a piece of the underlying software was called Eliza, and this was an application of it called Doctor. So here is an actual bit of the text, and a kind of apocryphal story about the whole thing was he eventually became spooked by it, and the point at which he became spooked by it is that his secretary, who knew it was a machine and had been working with it as a machine and was his secretary at MIT, she was going through this Eliza routine, and at a certain point, she asked him to leave the room. Right, the point at which what she was giving, she wanted to keep on giving answers, but she didn't want him to hear the answers. Right, that was the point at which the machines become anthropomorphized. And the interesting story about Weizenbaum is that he, 10 years later, in '76, he wrote a book. Which was a book about what a disaster technology is in a whole lot of ways. Now, in fact, he's too negative, and the story goes on further where the inventor of AI, John McCarthy, wrote a vitriolic, poisonous review of this book. So that's just a piece of intellectual history, if you like. But the main point here is this kind of psychological game the machine's playing, and it's 1966. Well, actually, he started this in '64. So, and the key article where he published his results was '66. That's a long time ago. So that's one bit of the technology, which is this dialogical thing, which plays a game with you by asking questions, but the questions then inform it about you, right? So, and so on. By the way, the other aspect of it, which is very interesting, is that it tries to be agreeable, because the one way, if it was disagreeable, the conversation would end. So it's got a whole lot of intrinsic emotional biases built in it as well, as does ChatGPT in exactly the same way. The interesting thing is the insights from '66 are still the insights we might have today. Now, large language models, there's a bit of a historical story here as well, but these are also really, really old. So the idea of language models, I don't know whether people can spot who this person is. He's a relatively obscure person, a profoundly important person politically. I'll tell you about that in a moment. But his name is Robert Mercer. And we're proud to say that he got his PhD at the University of Illinois in the 1960s and left in computer science, and he left the University of Illinois to work for IBM. And until then, computer approaches to language had been based on the fact that we can find some semantic essence in language the way Chomsky does. There's nouns and verbs and there's transformations and there's a logic in a sentence and a logic in language. And if we can program the computer with this, that will, work miracles. Well, in fact, it fell apart and it didn't work. And the US government in the '60s did a review of all the NSF grants using this paradigm. Nothing had worked. And they said, we'll give up on it. So when they come back to work on it, he is involved in a key way in inventing the idea that we will have a completely semantically agnostic way of dealing with this. And it's simply about the words that statistically appear beside each other. And it doesn't matter what the meaning is. The meaning is kind of completely irrelevant. So this is the basis of large language models. Now, how did he take his large language model and put it to work? He firstly made a fortune as a trader, derivatives trader and whatever, Renaissance Technologies, became a multi-billionaire. And then he put his money to good use as well, and his intellectual work as one of the founders of Cambridge Analytica, and was just probably decisive enough to get Trump in. He's a very conservative person, to get Trump into the White House with these technologies, because as you know, well, you may or might not know, Cambridge Analytica applied these technologies through social media, such that by the time the Trump election was in full swing, they were putting out 60,000 different advertisements per day on Facebook, tailored around the profiling they'd built using these large language models. So look, this is nothing new, and this work he began doing in the 1970s. So You know, if we just quit the browser, it's trying to log me in all the time to the internet. Sorry, I'm going to just quit the browser because otherwise it will send us crazy. Go. I'm just trying to drink it.
Did you have it in there?
Right there.
Excuse me?
Is it up there? Yep, yep. Okay, great. All right then. So now I'm going to hand it over to Mary, who's got some conclusions about this, and ultimately we say this is a disaster in a number of ways. But Mary's will conclude about this before we go into the second point.
So what I'm going to share with you now is that we're going to make a case right now, that the generative AI using the chat bots, the large language models, are deeply harmful to social understanding of knowledge and learning in the following 5 ways. We're going to suggest 5 ways in which they're harmful. And then in the second part, we're going to suggest there are ways that you can make it positive, but we have to be aware of what these 5 ways are. And the first one is about sourcing. I think Bill said that already. The machine buries its sources. I don't know how many of you have used the large language models, but it buries its sources. And not only are the sources opaque, but if you ask for references, they will give you good-looking references, but they're fake references. Right? So, that's what you get when you ask them for references. In contrast, one of the great intellectual achievements of modern knowledge has been that we rely on credible sources. That matters in the academy, it matters in knowledge making. And to validate knowledge claims, we need to interrogate their sources. In schools, we call it critical literacy. In the academy, the credibility of sources depends on a number of variables, right? Qualifications of the researcher, the credibility of the publication venue, the rigors of peer review. In the generative AI, however, as we discover when we use it at this point, who knows what it'll do in the future, but in this point, they are entirely hidden. The software is a black box by design. So that's the first caution about the issue of sources. The second one, our second point is about facts. The machine can have no notion of empirical truth. It doesn't have that, right? The priority of generative AI is to produce convincing narratives, right? That's what it gives you. It's a genre machine. It produces genre, whatever. You want to put a medical thing in it, it'll give you a narrative about medicine. You want to put something else in it, it'll do that. It harvests ostensible facts found in the textual sources, but without being able to verify them. It also invents non-existent facts when it needs to look plausible. So if it doesn't have something, it just kind of makes it up. So our third point, right, so we have problem with sources, a problem with facts, but our third point is an issue about theory. The machine, earlier people were talking about consciousness and intelligence and stuff like that in relation to machines, but it has no conception of a theoretical frame itself, right, the machine, or a disciplinary practice. At best, what the generative AI picks up is latent semantics in the chance of character collocations, right? That is, it can't make connections between dogs and kennels, right, of its own account. It just finds what's nearby, right, the collocation of characters, and gives that back to you. And by contrast, again, disciplinary frames in whatever discipline you might be interested are created by human practice, which rigorously frames ontologies. And these are the product of social intellect, and they're constituted through validated systemic knowledge methodologies that have been codified in practices of observation, multi-perspectival corroboration, critical reflection. In generative AI, none of these things happen. And Bill came up with this term to kind of describe what they are. He calls them I can't say that word, scostastic parrots. That is, they just mimic what's out there. And they regurgitate what they have copied from a mishmash of textual sources. Now, our fourth one, and this was spoken about earlier, is the issue, or this morning, the issue of ethics. If a machine is socially well-mannered, and Bill said earlier that it is not because its sources are necessarily that, right? Generative AI depends on massive textual corpora. We know that. Everything that has been written and produced can be captured. And the reality, and this is really important, and I think it came up again this morning, of human legacy texts that are based and are rife with racism, sexism, homophobia, along with a whole bunch of other factors. In fact, I looked up when we were kind of thinking about this, how many women writers have there been? How many women have been published? How many people of minority background have been published? What's out there in the language, right, up to this point in time? I know there are some changes more recently, but up to this point in time, it is a very biased corpora that is out there, and we have to be aware of those biases. However, human programmers create filters to override these truths in the generative AI. Extensive filtering happens by humans, right? So you think it's just free and open, but the humans who control it make sure that that happens, so that the moral frame of these human imposed filters, however, is buried. Just like the sources are buried, these filters are buried. You don't know what filters are out there. We don't know it. So whether Big Brother is a nice pseudo person is less relevant than the fact that the generative AI, they're big brothers too for us. Invisible shepherds of our morals. They won't allow some words to come up. They won't allow some issues to come through in order to avoid displeasing people or upsetting people in ways that can be offensive. Okay, so the fifth point in our, remember I said we have 5 points. The fifth point that we need to be concerned about is what we call critical dialogue. In order to be a good interlocutor, the machine is skewed towards being uncritically affirmative. It's going to be nice to you all the time. The chat part of the technology of generative AI plays through a feigned anthropomorphism. It's a good conversationalist. The chatbot always remains polite, even when its human partner is offensive or critical. Right? It maintains the illusion of understanding, but conceals its lack of understanding. So these are the 5 issues that we believe are and can be harmful to meaning making, to the way that we use it in our everyday practice, and we have to be mindful of that. But we're going to move now to what might be possible, but in specific circumstances, not just, it's very hard to be positive in a generic sense, but in specific contexts, what can you do that might harness this thing that has these 5 problems associated with it in a way that can produce productive meaning for our students in our education system?
Okay, so that came up again.
Doesn't like what we're saying.
No. How do I just get out of what? I'll turn my lights on.
Can you turn the Wi-Fi off?
That's what
the problem.
turn the Wi-Fi off.
That's what it's doing to me.
Yeah, Wi-Fi off.
Wi-Fi off. That's it.
That's it.
It's not Firefox.
Okay. All right, this is the next thing, is we thought, okay, what can we do with this thing? So it's very, very problematic. But we have been building this environment, which you folks will know well, because one of the modules in here is the event module. But we've been building another module in here, which is called CG Map, Common Ground Map. And what we've been doing here is, this is the workflow we use with our students. Mary mentioned peer review, and the yellow bit's the new bit, right? So we've been, what happens is the learners start a project, and we have an embedded rubric, okay? And I'm going to show you these in a second. Then typically 2 people give feedback, human feedback, and then there's also a kind of an internal cycle there where they get feedback on the feedback. Then what they do is they revise using the feedback and the rubric. So they do a new version. Now, this is about collaborative knowledge building. But the bit we've added, which is the yellow bit, is we then get ChatGPT to give a review. And I'm going to show you how we limit, it is of some use, and we'll show you what the use is. And then what we got them to do is get them to do a comparison of the AI and the human review, to do a review and a change note. This is what I did, this is how I revise my work. And then it gets published. So this is about collaborative knowledge work. So I wanted to put it in that context there in terms of what the students do in one of these projects. Now, what we also have, and this is really a side point, it's not the main point, but we are, as you can see, if I go back, there's a lot of complex activity happening in here, right? So there's ratings against multiple rubrics, there's qualitative comments against multiple review criteria, there's feedback on feedback, there's a hell of a lot of data being created. And in other places as well in Scholar, we use the community application as well for classroom discussion. And what we're constantly doing is data mining this. So this is not our main point, but just need to see this in the context. So that in the middle there is, we've got 3 sectors: knowledge, demonstrated knowledge, focus, which is the work you've done, help. You start off at 0, the petals grow. This is a thing called an Asterplot. And you can see here that this is a class with, from memory, this particular class had 30, 40 students. There were 2,300 pieces of actionable feedback on 364,000 data points. Now, no human teacher could ever do that. So one of the low-level AI things is any form of calculation which is more than a teacher could do. But if you click on any one of these petals here, we give you, the student, a full explanation as to how that's being calculated. So every student has one of these Asterplots. This is one I have for the whole class, or we have collectively for the whole class. Start off at 0, and we can then set a number of expectations about what performance are in that context. So I'll just jump forward now. This is an example of an AI review. So on the left there is a piece of text that's been written by a student, and on the right, no, this is not the AI, this is the human review. Okay, so here on the left, you can't see it here because these are the highlights drop out when you're working on this side. So, but what you do is you highlight something over here, and the map part of it is, it's like a series of post-it notes that come up, and you can build a visualization of your analysis. And what we've got happening here is we've got, this is looking at conceptual stuff. So you link the science of reading to the eye of differential instruction, you're able to provide, and this is, it links to conceptual things, you're able to provide strong examples, blah, 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 blah. So this is the feedback people are giving, they're building, this is the peer reviewer on the right, on the left is the person's work, and this is just a small snapshot of that. Now what we do is exactly the same, that if I go back here to the conceptual one, which is the one on the right, that's the human speaking. And this then is the machine review. And I've made it big enough for you to be able to read it. It's kind of trite, but it's also kind of helpful. So what we ask our students to do is to say, look, what's different about these, and how, so that, which, their insights are kind of really, they're subjective things. This is uncannily like a human, but it's not a human. I know it's not a human that's written this response. And I'm going to tell you in a second how we get this, how we do this. The second thing, here's another example here, by the way. The one on the left is the human review, and the one on the right is the machine review, which feels like a machine review. Now, what we've done in Scholar to do this, by the way, is we've connected into OpenAI via an API, right? And what we've done is we've I'll go into the next slide. So what we do is, people may or may not know that we've got this kind of epistemological theory of learning. By the way, these rubric items could be anything, but I'm just going to show you the ones that we've actually used. So what we want to do is we want to get both humans and the machine to talk about experiential, empirical things. That's the first quadrant. The next quadrant is conceptual and theoretical things. The third one, if we go down to the right here, is about critical analysis and functional analysis, and the last one is about applications. So these, for us, are things one does to know, and the phrase we use is these are things you do to know. And then I'm only going to show you this next slide to show you the extent of the rubric that we give to the humans, and also the extent of the rubric we give to ChatGPT. So this is, see the color coding there? So I'll go back. Got a mental note of the color coding, right? So behind each of those small common sense phrases is actually quite an elaborate rubric with keywords and description of levels and blah, 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 blah. So what we do is those 8 things in the circle, plus 2 more around communication, we, via the API, we go through ChatGPT, or ChatGPT analyzes, or we analyze using the large language model on the chatbot against these prompts, these large extended prompts. And that actually produces reasonably good stories. Now, what we're not asking in these prompts is for any facts. And we're not asking for any theory, because we know ChatGPT is no good at that. What it's quite good at doing, though, is if you give it a really elaborate prompt, it will kind of parrot back a relationship between the prompt and the text, which is actually reasonably insightful. So what we're doing is we're using it in a very, very limited way. Mary's going to conclude about that now, but maybe before you do, does that kind of make a little bit of sense what we're doing in terms of, obviously in a talk like this, we're going to say something very schematic. And we've been very fortunate to have an amazing programmer who's able to connect via API into Scholar as well. So anyhow, Mary's got some things about how to, a couple of things. One thing I want to say is when I grow up, I'm going to become a prompt engineer, because I read on Twitter that you can earn $300,000 a year, and I reckon educators, what's the role of educators in the future? Actually, to be prompt engineers. Actually, it's a funny, which is how do you, so that's what we've done here. We've actually engineered the prompts in the chat to give the students, pretty reasonably interesting feedback on their work.
Now, at our university, and I know in universities in Australia and maybe universities or schools where you work, are panicking about how students will use what the AI chat can give you very quickly. And so we had to think, yes, that's possible, but what do we as educators do if that is out there? How do we use it in any way at all? And Bill's not joking about being prompt engineers. We as educators then have to become prompt engineers and help the learners understand how they too can be selective in choosing what they ask. However, what we've tried to give you an example of is in our pedagogy. Our pedagogy relies on those knowledge processes that Bill put up. Our pedagogy relies on peer-to-peer feedback. It relies on collaboration, right? So if they are core to us, how do we improve the peer-to-peer? That's the bit that we were looking at. And that's why we thought, let's see if this thing can produce anything that improves what our students give to each other at a human level. So we want to get, remember we said it's narratology. Can we get optimal narratives, from framing up in the way that Bill just showed you? And we've come up with what we think are 3 things that matter if you're an educator that wants to use this AI chat that you have to do, right? And one is you need to provide an epistemic framework, right? In order to prompt the machine, you need a theory of knowledge applicable to the kind of learning that is the focus of your work. And in our experiment, as Bill said, we used a rubric, framed it around those eight processes and our epistemological theory of learning, and the genres that we were wanting from them. So you have to decide what your epistemic frame is in order to inform the learners. And the second one is the empirical frame, because it really matters, the content of what you're doing matters, and it requires the learners to bring very able, I'm sorry, my language is gone today, I'm so tired, I can barely speak, variable facts to the machine. So we don't ask, as Bill said, the generative AI for anything factual. Remember, we've called it a black box, that you draw on. And so the narrative that is generated by the prompts is only valid to the extent it works with the facts that have been already fed and verified by the human peer-to-peer responses. And the third point we like to make, or we found as a consequence of what our experiment delivered, is that we need an ontological frame. That is, bring the theoretical frames of the disciplines to the machine. We've been working with the medical field in some of the projects that we have, and there they have formal ontologies that you can draw upon as part of the biomedical practice and as part of the rubrics that you can produce. But all the disciplines have some form of schema that frames up the discipline. And so we need to do that as well. So those three domains are important: an epistemic frame, an empirical frame, an ontological frame, to scaffold the kinds of questions that you're going to ask of the generative AI in order to get neatly framed responses that are useful. Now, our students have found that the AI, and remember, this is the first time we've done this. It's experimental. We're not quite sure where we're going. They say that the responses they get are different, right? And it's different in a way from what the peers gave that is positive to them rethinking what they've done and expanding it or changing it or adding something to it. But if we hadn't framed it up in the way that we've suggested, what would have come back would have been entirely arbitrary. Right? In order to improve the process, we believe that you need to have those three frames designed into the process of use of this kind of new technology in the writing processes across our disciplines in the education sector and higher ed. So, Bill, we're going to go back to theory now.
Back to me.
Yes.
Are you going to be a prompt engineer when they prompt you?
Okay, so look, you know what this is about, just to sort of put another gloss on this. This is about these kinds of filters. In other words, using the prompts in a very specific way. So the epistemological frame you saw in that theory of knowledge, which we then specified in the big table in a whole pile of detail, because the machine is good with detail and can process it all. The empirical frame is we don't ask it about any facts at all, but we ask the students to make sure their facts are verifiable and the sources are correct, and we get the peers to check all of that. Don't ask the machine to do any of that because it will tell you untruths. And the ontological frame is in domains which are very well specified. And Mary mentioned health. So we've got we've been working in medical education just as a trial site, and it's incredibly well specified for all the wrong reasons, by the way. The wrong reasons are to do with, in the American case, in the insurance system, where you've got to know that you've got a condition of the knee, which is worth $600 when you hurt it or something. So, but it's actually incredibly well specified. So what we've got a project going now where we're mixing. The epistemological frame is rubrics around doctors' notes, and the ontological frame is the ICD, International Catalogue of Disease. What's the C in Classification of Diseases, which was actually begun by, none of these things are new, Florence Nightingale in the 19th century. So in other words, if we bring these very, very concrete things to the prompt, then it spews out quite nice narratives, which are kind of helpful. In the same way that grammar checkers are kind of helpful and sometimes wrong. So that's what we're working on. Now, in case you haven't had enough, this is how do we're going down, digging down deeper now, which is what are the problems with AI in general, right? And so again, I want to refer back to this, which is general intelligence. We can have this darn thing, which is a machine which mimics human beings. No, it pretends to, and sometimes it cons you into it. And one of the very important things is, I want to start with this definition. Where does the word come from? This is where it comes from, John McCarthy, who I mentioned earlier, who wrote the vicious review of Weizenbaum's ELIZA paper. And this is the key phrase, which comes from the 1956, it was published in 56, the 55 seminar at Dartmouth Seminar. So he invents the phrase. And we're now tethered with this damn thing in a whole lot of ways. And it's a really, and there, by the way, there's the reference to the article, the actual proposal itself. Now, I want to have two definitions of artificial intelligence. One is a broad thing, which I'd call machine intelligence. So remember the Astor plot there, where we counted up all the data points and we more than a teacher could ever do. In a way, that's profoundly intelligent and also profoundly dumb, because it's counting up tens of thousands of things, but it's more than a teacher could do. Then the machine learning, the narrow definition, which is by and large the one that's used these days, are these various forms of machine learning, supervised and unsupervised as well. And interestingly, we end up in all sorts of behaviorist, we fall back into the discourse of behaviorism by the time we're in this space down here, which is kind of interesting and revealing. Now, Alan Turing was the person who coined the first phrase, machine intelligence. And the Turing test is profoundly misunderstood. So Turing was a very funny man. If you want to read this article here, Computing Machinery and Intelligence, it's a very funny article because, he takes on religious people, he takes on all sorts of people about this ethical question of machine intelligence. And the funniest thing of all is the Turing test. So the Turing test, which is this is the Turing, the machine intelligence idea, before I get to the Turing test, this is the Manchester One, pretty impressive looking machine. And one of the things that I really like, that's a little, he wrote that thing circled in red there, which says, what does this mean? So this was from the very start doing things that human beings couldn't do. And from the very start, this crappy machine found prime numbers, which there'd be no point in a human being finding prime numbers this large, but the machine could find them. So in a way, what's impressive about artificial intelligence has been impressive all along. So here's the Turing test. We've got a computer there, we've got B here, and this is not the diagram, but this is kind of a diagrammatic version of what was in that article. And really what it's about is, can the machine trick C, right? It's not for one moment does it say A and B are equivalent in their intelligence. Now, what John Searle did in a very famous article later on, he said, oh, look, what if A is a person with a Chinese dictionary who doesn't know Chinese, and what if B is a Chinese speaker and C is asking questions, right? The Chinese person with a Chinese dictionary can do very, very well. So, you can't, of course. But what John Searle didn't get the joke in a way. And the joke was that Turing wasn't talking about it being comparable. He was talking about the appearance, the trick that the machine can create by knowing. So if the machine does know Chinese, look up tables there, it might actually know a lot more Chinese. In fact, it probably will know a lot more Chinese than any Chinese speaker if it's and again, it's the appearance, it's the trick. Now, the other part of this story, which is, I think, really important, is this is the person, Warren McCulloch, who first, in this paper on the left, which you can read at your leisure, I'm joking in a way, came up with the idea that in binary notation, we could mimic processes that go on the mind, right? But what he says in the paper is, this is just notional. Do not think that minds are binary. And all the stuff you hear now about neural nets, in fact, all that computers can do is work with binary notation, which then gets layered out into other things, numbers and statistics and a whole lot of other stuff. So one of the problems with this is to think that in any way, mechanically, it's similar to a brain. A brain is a complicated biological event with lots of chemicals, and really, we don't have a clue how it works. We know so little that it's kind of embarrassing. Now, what John Newman did, John von Neumann did, is that he took that article, this article over here was published in a very, very obscure journal, and he found this article, or he was recommended, the article was recommended to him actually, someone else had found it, and he then built the first binary computer. So, the idea that we could actually, build out this binary notation to do computational work, because before that, not even Turing thought up the binary idea. So between McCulloch and Neumann, this is what happened. And of course, this is where it ends. Dr. Strangelove? Well, Dr. Strangelove is modelled on von Neumann, who was an incredible enthusiast for the atom bomb, a very, very heavy-duty Cold War warrior as well. By the way, came to the University of Illinois all the time because our university was complicit in building all this stuff. And what we'd do is he'd drive from Princeton to Los Alamos, and eventually we got the atom bomb. That's just a little bit of history. Now, the other key person is Claude Shannon, whose insight is to use Boolean algebra to turn binary notation into elementary forms of logic, if then, all that kind of stuff. So now our argument now, and this is an argument that Mary and I just spent 2 volumes of a book and still figuring it out, is that what happens when you take the meaning stuff of the world and you have to force it through the choke point of binary notation. Everything has to be forced through the choke point of, what can't you force through the choke point of binary notation? So, I take a picture, meaningful stuff, there's the mountain, and then lo and behold, I emailed somebody, but in the middle it's gone through these zeros and ones, which are utterly meaningless, senseless. But what are the kinds of, and the word we use to describe that process is transposition. So just to come near to a conclusion now, human and machine intelligence are so different that even to use the same word is a travesty. We have a lot.
You saw this morning.
Oh, that sent me crazy. Sorry. That's another whole story. That little girl, yeah, again, it's a fabrication. It's again thinking that, yes, it's the little girl passes the Turing test, which is, yes, you've been conned kind of thing. So firstly, the brain is more than binary. That's the first thing. So anybody who talks about neural nets, there's elaborate stats on stats on stats based on what's beneath it is binary code. So brains are much more than that. But also for the meanings in the world, we smell things, we sense things, we feel happy, we cry, we scream, a whole lot of things. The bodies are part of our meaning systems as well. But the other thing is, meanings are in our context. Look, I've got this object in my hand, I've got this object here, and this room is a kind of an object. And the meanings are actually outside of our minds. They're in our relationships with the material world. They're deeply material, which can only ever be digitized in a secondary referential kind of way. And again, getting back to this point, it's what's the nature of this secondary referential process and what are its limits? So one of the things is this is kind of by way of absolute conclusion, that in fact, rather than artificial intelligence, we want to talk about our relationship with these very, very specific machines. So binary notations at one level, chatbots are another level, large language models are another level. These things are in no way human, but we have these very interesting relationships with them, and it's the dialectic between those things as very different events. So the idea of artificial intelligence is basically a terrible idea, and the idea we're trying to work on is this idea of cybersocial systems and cybersocial learning, and that's how in the cyber world you might connect with us. So that's our kind of, sorry to have taken you on a big tour through a whole lot of stuff, but these are things that we've been trying to get our minds around in both a theoretical way, historical way, a philosophical way, but also, rolling up our sleeves and building software as well. So, okay. And Mary can conclude because...
I just want to say, and both of us are a bit skeptical about the way in which AI is going to change education. Right, it will have an impact on it, but only if we're able to have that cyber-social relationship and design the kind of relations we're going to have for specific contexts and for specific purposes. I mean, there's such a huge debate and such a lot of argument and such a lot of excessive kind of things that are being said about what's possible in this space. And we have to be a bit wary of that. And for us to become practitioners and designers and to understand the limits of the AI for teaching and learning and knowledge creation. And as we said, those 5 things that we need to be wary of, particularly now with the chat, the AI chat, which supposedly is going to answer all our questions, write out job applications, answer the essays, do all the sorts of things that make everybody nervous. But thank you for listening to us. We are constantly trying to think about these things in terms of our own specific contexts, and we hope what we share with you is useful to some extent. So thank you. You can ask questions.
Do you want someone? You.
There you go.
Thanks, Jose Luis. Let's see this one here. Yes, no, yes. Don't worry.
It's okay, we can talk loud.
Yeah, we can talk about it. Okay, yeah. Yeah.
Yeah, I think it was really interesting. I like the analysis of the question is, thank you. The question is, so you've convinced me that there are actually useful things that ChatGPT can do in education, but I don't think that solves the problem that the universities are so worried about. Namely, so yes, we can use it, but the students can still go out. So question, if we don't go to the blinkered vision, what else can we do? So that's the question. And my comment is on, so you talked about the context of education. I'm also concerned about the context of peer-reviewed publishing and the use of ChatGPT or those sort of things in that context. And I get the sense from what I've read so far that most publishers and editors are hesitant to take a strong stance. The science and associated journals are among the few that have taken a strong stance and said no, not allowed. We'll reconsider. But most of the others have just said, as long as you say that you've used it, we'll consider that. And so that seems to be problematic.
I mean, saying that you used it actually means saying that I'm going to use sources that I can't cite. So it's a real problem. The kind of facetious thing is that Dr. Broom is the only way to actually get away from it. And they're very easy. Firstly, the GPT detection software is unreliable, but it's very easy to game. You just game up with a few typos, or putting in an ordered expression. So, and I can't see any way around that, quite frankly. So it has kind of set the proverbial cat amongst the pigeons. But by the way, it's no different from, and look, I think citing ChatGPT is a terrible, terrible idea. It just says, I've used something which is synthesized sources where it's impossible to know what the sources are. And don't forget, Chat doesn't know what the sources are. What it's done, it's taken facts and fake and mixed the whole up. You can't know what's fact and what's fake. You cannot know that by definition. So it's that cat amongst the pigeons. So I think all we've done here really is say, how can we use it in a narrowly circumspect way? And how do we use it to be helpful? Right? But it doesn't solve those other problems.
Except that it is evolving by the day, the versions are evolving by the day, and the counter development is happening too about creating the kind of tools where you might be able to detect it. So it's hard to say anything about this stuff because it's moving all the time. It's not like your textbook or your encyclopedia or like your library. It's just constantly moving. So,
right, and now I'm going to say the opposite. It hasn't changed since 1966, right? And the basic problems and basic issues haven't changed, and Again, our argument on AI is that it hits absolute limits. It can't do more than that. So I reckon Bard's going to be better than ChatGPT because Google has stolen the laws of intellectual property in a uniquely avaricious way. So they come into our libraries, the University of Illinois and other places, and they'll take everything. And what they do is when you Google a book search, and it's a copyright work, they'll say, oh, you can just have page 84, right? But that tells you they've copied the whole work without permission, and they're using it for their business, the whole work, and they're giving nothing to the publisher. Now, my prediction is that Bard will have everything, which is the scan. And once they get their parameters right and get it working, it will be definitively that. But it doesn't solve the problem. I don't think it's going to be around any of these problems, around fact, around theory, around the 5 problems that Mary outlined there. No matter how good it gets, it's never going to be better than it was when Robert Mercer first thought of the idea, and when Joseph Weizenbaum just thought of the idea. They didn't have much data. But the basic paradigm is the issue.
Yeah, and the problem is the language we use to describe it. We call it intelligence. Even this morning, we call it consciousness. Like we slip into these words that make us think it's more than what it is. And
then the question becomes exactly what is it, which is why again at the end, what is it? And by the way, it's fantastically helpful. It does counting like you could never imagine. You look things up, you know all of this. So this stuff is extended out of human capacities hugely. But it's nothing like this.
Yeah, we don't have another one.
Oh, one down there, sorry.
Sorry. I have a specific question, I guess, and it's the same question I asked this morning of somebody else, but as you work on embedding the GPT through the API for the feedback process. Again, this is something I've been interested in using it for as well, and we're seeing, Khan Academy is developing a tutor using the API as well, and I'm curious about what you think about automation bias, and when your students are going through this really pretty amazing recursive process of getting feedback and feedback and feedback on their feedback, and then suddenly they're given feedback by GPT. Well, yeah, just to what extent are you concerned about automation bias and the ways in which some students might start to wonder and sort of
the confirmation bias stuff is what it does. That's just in the nature of these agents. So they're not very critical. And I didn't. If you had time to look at those 2 examples I've got there, the human example was gently critical and made some really good suggestions, whereas the chat one was, its bias was being positive because it's about being a conversational agent and keeping on drawing you in. So, but you just, I suppose, the users, you just got to know that and learn these nuances. By the way, the nuances are not in the source text. The nuances are in the filters. So one of the things which is really dishonest, actually, in a way. First, one level of dishonesty is they copied everything in its paragraph. The second level of dishonesty is the level of filtering, which is manually added. And it's like Big Brother. Now we might say, oh, it's great they've wiped out all the sexism and the racism, which they have. Like it's in the source text, but they wiped it all out as a form of, being positive or whatever. But there's no well, firstly, it looks as if the machine is like that. It's not. It's humans that have modified the machine to be like that. But who are the humans and what are they able to do and what's their framework? A very cute thing to do, by the way, and I love it. Somebody said, write an essay by Jordan Hicks on the nature of gender, in the style of Jordan Hicks on the nature of gender. And of course, what it produced was golden because the machine won't let it do that. But you
don't want his biases to.
You're right. So the machine is still all those things out, even though there'd be 1,000 source text out there which would do it brilliantly. So, there's a kind of thing about who's in control of our models. That's the question. Now, it may well be that they're well-meaning liberals in Silicon Valley who are earning huge amounts of money. I don't know. Whatever it is about them, it's problematic.
I suppose just to clarify what I'm talking about is the fear that students go, oh, well, the computer said I should do this.
Right.
So I'm gonna prioritize GPT's feedback over my peers or even over my teachers because we know that people will drive their car into the ocean if
Yeah, that's why you're
And,
gonna.
and that level of criticality, I suppose.
So that last phrase, cybersocial, it's not just cyber, it's cybersocial, it's a part.
And we warn against that.
A critical goal.
Yeah.
There's a lady back here.
Okay, yeah, we have a, yes, you have any question over there? Yes, okay.
I know, they put it.
Yeah, it reminds me also of the, anti-plagiarism software. Students have a right to opt out, which is good, because I'm just as good as that software at spotting plagiarism. You read it, you recognize it, I see, I recognize that sentence, I Google it, I find it, and there you go, you plagiarized. But ChatGPT, I like the way that you taught students to use it in a good way, because I did a demonstration to my business students. I said, pick a topic, something that you know enough about, and see what mistakes it make. But even then, they said, yeah, but the sources were good, and it was technology, it was, if it's something very scientific, yeah, they're good, but it came out, I asked give me 15 French-speaking Indigenous Canadian authors, and some of them were not Indigenous, and one of them was not an author. She was a very important person, but not an author. So, I'm sorry, I made a mistake, then repeats the same mistakes again.
Ask you to write your bio.
Oh yeah, I had to write a poem about my sister, it was great. I had to write a poem about Linux, it was okay.
They're educators, and when students do use those tools, they're not learning anything. They're really not learning. They're not learning research skills, they're not learning writing skills, they're not learning content knowledge. And it's on my value actually in terms of their education pathways. So, even they will understand that it doesn't help them if they trick someone to get through an exam.
Okay, and I think we have the last question here.
If I go back to the first prompt that we got, which was about the Peloponnese Railway, and I wrote it, I'm a student that you gave me to do the exercise, and I said, give me all the sources in a summary so I can write my essay. But they have to be real sources. Why not?
It doesn't operate that way.
That doesn't operate.
I can't.
It doesn't have.
But its prompt says with references.
Yep.
If you said real references, I'm trying to cheat the cheater.
Always give you a plausible answer.
But that sounds like someone prompted it to be, for example, polite. Does it have a programming in it that says make sure you don't use obscene words and you're polite and you're gentle and write whatever you like? Because what it does in effect is mine all the info that's out there, right? So a lot of people, it probably looks into all of the garbage that it gives out. It's probably written somewhere by somebody who just uploaded garbage. It doesn't just create it of itself.
It's the parrot with filters. So
Right.
The parrot can't say, I'll let you say that.
Right.
So filters and now things will change, but remember it only goes up to a certain year and everything.
Well, no, the new ones.
What's available online, otherwise it knows nothing.
Also, they don't have access to as much access to the web as Google does. So the engineering will be what Bard's like, but the basic problems will be also there.
But as an educator, I live very optimistic about this new menace that we have in our heads.
No, what we try to do is encourage you to use it usefully. And the best thing it does is it spins interpretive yarns. So if you cut out the facts, and you cut out the discrete stuff, and you cut anything that's logical, and you apply these filters, it won't produce what's reasonably helpful, to be quite frank.
I'm trying to at least use it to get the facts right. So
No,
somehow you can prompt it to give you just.
you can't. Part of the reason why it can't know what a fact
It
is.
doesn't know what a fact is.
Yeah, but it knows what a citation. Give me info only based on online journals.
It knows what a word is, but it doesn't know what a fact is.
That I understand. Thinking about your 300,000 job, and because I wanted to, can't I prompt it to say, find me this answer only from online credited journals?
He doesn't know what they are. You see, you think it thinks, it doesn't think.
I know it doesn't think. I'm trying to do some manual work for me.
Project to put everything in Biomed Central, and to have a more restricted database which comes out of Biomed Central. But you know, whether it's possible for you to know that
only medical journals.
Yeah.
The next.
Well, no, it doesn't have enough text to operate. Also the legal journals. It has to match them up. Anyhow, we better stop.
Lovely. Thank you. Great work.
Thank you. So we will be back tomorrow at 9 o'clock in the morning, okay? Tomorrow morning.